This lesson has been developed in the framework of SCILED project. Module 2, Footwear Sustainability. Unit 3, Materials and Technologies for Sustainable Footwear Manufacturing.
Lecture 3.5 Sustainable Manufacturing in the Footwear Industry. Introduction. Today's society is increasingly aware of the importance of the environment and the conditions under which products are manufactured. The footwear industry must observe the added value that the sustainability of its processes provides to its products, improving quality and efficiency, being compatible with its economic objectives.
Main problems in the footwear production process. The administration of a company must understand the production needs, the importance of planning, organizing a constant and uniform production flow, and the machines and tools necessary to carry out each operation. The goal should be to deliver on time, without overproduction, and if possible, without rework or rejection. During production processes, such as cutting, sewing, making room, the emphasis will not only be on quality, productivity, or energy savings, but also on how to execute operations to ensure maximum machine life and optimal results of work. Following best practices will help make shoemaking more sustainable.
Pre-production. The design process should be organized in such a way as to minimize the number of physical samples and with the focus of reducing the environmental impact. Modern CAD systems give designers new tools that allow the creation of virtual prototypes while calculating the environmental impact of this design. Modern CAD software also offers the designer other options and recomputes the sustainability of each design. 3D CAD images of shoe designs can greatly speed up the creation process, save a lot of effort and the resources invested in developing and prototyping shoe models that will ultimately not be part of production. Allows to calculate in real time the consumption of model material, thus optimizing consumption and minimizing waste. It is essential that the product acquisition and development departments are continuously informed about new materials, new technologies and machinery for the industrial production of footwear.
Cutting. Currently, dealer's cutting tables are the most widely used. CAM machines are used for taking samples due to their great flexibility. The CAD system communicates the geometric data of the pieces to be cut to the CAM cutting table. The material, leather, is placed in the work area of the cutting table and the pieces are projected on the material. The most important feature is that the positioning, nesting of the pieces to be cut can be changed several times until the optimal final cut design is found. The relationship between investment cost, operating cost, speed and flexibility that these systems offer compared to traditional die cutting must be calculated. Most CAM systems allow simultaneous marking, numbering, and punching of parts. When comparing the return on investment of a traditional cutting machine and a CAM machine, the possibility of grouping the operations mentioned above and the optimized use of the material to be cut should be taken into account.
Pre-stitching. There are three processes that take place in the pre-stitching: splitting, skiving and ironing. Splitting achieves a material with more homogeneous properties. A non-homogeneous material requires additional pressing, ironing, hammering at lasting or creates problems in one of the subsequent operations. Improper work causes material damage, and poor splitting is one of the most common causes of rework or reject. Automated skiving machines increase productivity and can group several different operations, saving 3 or 4 manipulations. As far as ironing is concerned, it is essential to control the pressure, activation time and temperature used. Moving away from the recommended parameters will cause rework or reject. Stitching.
Automated stitching machines are probably the most sustainable solution for the stitching department. Large automata for functional stitch require special supports for each shoe size and for each type of seam. These systems are used for large production series. An experienced designer who knows how to use centerpieces for their shoe models can save a number of supports and therefore increase both efficiency and sustainability of the process. A bad job or lack of maintenance can have the opposite effect even with new and automatic equipment, and on the contrary, old stitching machines can work well, as long as they are properly maintained, regularly cleaned, adjusted with suitable parts and quality is used of decent thread.
Making room, assembly. The machines in the assembly room have the greatest impact on the final quality of a shoe than those of any other part of the process, but in terms of sustainability they require very large spaces and the expenditure of large amounts of energy. The subsequent molding process can be made more sustainable using standard profiles, which avoids the cost and resource expense in new forms of molds and reduces the risk of rework and reject. The keys for not having reworks or rejects after lasting are choosing the most appropriate components, good technical design followed in cutting and stitching, using standard profiles and perfectly adjusted tools, choosing the appropriate lasting machine, and the glue application method. Today, hot melts are increasingly being replaced by water-based adhesives. Soling.
The mistakes that are made during the soling leading to reworks or rejects or can cause customer complaints. Statistically, about 70% of all customer complaints are due to a poor bond of the upper with the sole. An automatic roughing machine will produce better results than an operator's manual labor, provided the upper material is homogeneous. Regarding chemical roughing, it uses very aggressive substances with workers and the environment, so a sustainable approach involves the installation of a gas filtering and retention system before being released abroad.
Finishing. The processes and measures for a sustainable finish are well known. Waxes and creams should preferably be used, avoiding aerosols due to the risk of emissions to the environment and expensive filtering systems, which, if solvents cannot be avoided, must be installed. In any case, if necessary, preferably use water-based finishing products.
The development of truly sustainable footwear begins in the design process. At this stage, it is crucial to consider the entire footwear value chain and all environmental aspects, from the selection of raw materials, manufacturing, packaging, transport and distribution, use and maintenance, to the useful life of the final product. Introducing sustainability and safety criteria during product design is essential to ensure that resource consumption is minimized. The sustainability criteria provided by the ecological footprint must be combined with indicators of environmental risk.